Hey, there's a calendar for this class. Okay, so when we're done here today, immediately I'm going to put a playlist together for your work for tomorrow because you really should be able to do some work today and ask me questions here at 2 o'clock or so if you have any struggles on that. The notes are going to start off pretty easy, then we're going to end with some challenges. It's definitely going to be a challenging end. So we'll see how that works. And then when I make this playlist here, I'll probably select no more than 4 questions per section. And I'll expect you to have that done before Wednesday. Again, we should have 2 components going on here on our 2 days just to solidify the information. So blah blah blah. There we go again. Chance to do work or the chance to show that we're still going to fall behind and not do stuff that some of us are doing consistently that I'm just going to keep mentioning. It is disheartening how many students are not actually keeping up with the stuff and doing it in a timely fashion. Can only just keep harping on it until we get everyone on board. All right, here we go. Let's get to students. So this is review. Nice, Ethan. Okay, do you remember these? Unfortunately, I think when I make this video, we can't hear the student, which is okay. I guess that keeps them, um, off the internet, I guess. Ethan, you ready? Hey there, Ethan. Ethan. Rudman, you got to know your numbers, man. 22 are towards the end of the alphabet. Sorry for getting crass. Okay, gotcha. So, what do you think you're going to do first, Ethan? No, it's a plus 1 squared. This is the solving quadratics where this was a specific method. And the reason we're doing this is we're going to solve square roots, which the steps you're going to do here, very similar to what's going to happen with square roots. So, what did you do first on these kind of questions? Absolutely. You'd isolate the square root by subtracting 2. What would you do next? Nope. You definitely want to divide by 3 because if you square rooted, you'd have to square root the 3. And then that would create a problem. All right. So now we got this squared isolated. Whoops. That was a little brain mishap there. I didn't want to show you that. Then what do you do to both sides in order to solve for that? All right, and it makes me sad how many students still don't know how to do this. We had our chapter 4, 5 test where we had to solve by using square roots when it's a plus 1 squared. Oh, Ethan, people make this mistake all the time. What's on the right side? No, thank the maker. Plus or minus. Okay, and it's it's really because of the absolute value thing, but it's really because of this. Ethan, tell me what works for x to solve x squared equals 9. What numbers work? 3 or negative 3 squared equals 9. So that is why that's what's happening with this. That's the real reason. And then what do you do last? And then what would that look like? I like how you said that. Stop the radical and then minus 1. And I get a lot of people writing it like that, which is okay. Usually they write it in front. I just want you to know that these are identical. And those that wrote this like this, totally fine. Just a little weird. We weren't like expecting it as teachers. We discussed it, us three. Like, how many students did you have write it like that way? And like, I guess it's okay. We didn't show it in the notes, but it's totally fine. Okay, so now look at that compared to this when I get the next students. And it's the whole point of us being able to do this. It's really not that bad. Hey, student number 19, Emily Ann. How is this one different? What does it have instead of a squared? It's a square root instead of a squared. But what do you think you're going to do first anyway in order to solve for the square root equation? You're still Still going to isolate. I'll write this way over here just for space purposes. A plus 1. I guess we'll keep those parentheses. I don't think you really need it, but that becomes 9. Then what would you do? So the whole point of this is we're really in the same mode. We want to isolate who, our thing that's, stuck in that square root. But then what's your opposite operation now? You square both sides. Now, there is no plus minus on this. That's only when you're square rooting, and it's only because of what I talked about with Ethan. Hey, what works for x squared equals 9? Plus or minus 3. All right. In this case, we only get one answer, not -9 as well, because -9 wouldn't work. And what's the final answer then? A equals what? 8. And then we can plug that in. 8 plus 1 is 9. Square root of 9 is 3. 3 times 3 is 9. Plus 2 is 11. So we see that worked when we ultimately plug this in. -8 would not work. You'd end up with or -9, and then subtract -10. If you tried to do two answers, it wouldn't work because you'd have an I number. So plugging it in. So only one answer in this case, not plus minus. So I should be able to ask anyone, what do we do next on this one? Keep it real simple on this beginning stuff. Evan, okay. What are you going to do first on this one? Subtract 3 that is not part of the square root. Do you think you're going to add 2 next? Yes or no? No, and that's what people do all the time. That's what people did up on this stuff. Those that don't know what's going on mathematically, they're trying to subtract 1 on this before they square root both sides. No, it's stuck in this, operation. So no, you cannot. So what do you have to do next? You have, you have to free this by squaring. Then you get, what's the final answer? And then if you plug that in, 6 minus 2 is 4. Square root of 4 is 2. 2 plus 3 is 5. So you can see how we do get that one answer. All right. So a very easy start. Oh, just wait. It's going to ratchet up. Student number 25, Sydney Stewart. Oh, I said your last name on the internet. You can sue me. Great. You get all my teaching money. Oh, I'll make so much money as a teacher. Not. Okay, Sydney, what do you think you're going to do? You going to add 1? Yes or no? What are you going to do? You are correct. Cube root, cube. What's 2 cubed? Good. Some people tell me 6. They add, I guess. I don't know. What's your final answer? Oh, this is so silly. 9 minus 1 is 8. Of course, the cube root of 8 is 2. So we could have been probably a little bit more challenging on that one. Oh, we're going to get there. We're going to get there. Okay, so basic, easy. Oh, not a so much. Okay, good. So we'll show that and move on to, I hit enter. Come on. There we go. Was that a repeat? Genevieve. Nice. Okay. Okay, Genevieve. How is this one different? How is that different than the others? What do you see that might be an issue here? So I have a square root, but what else do I have that the others did not have? Yeah. Yeah, there's this x. Okay, we're still going to do our thing, which is what? How do I get rid of that square root? But then whatever I do to one side. Okay, so then this is what I end up with. X squared equals 7x plus 8. Now, last hour, someone told me, I go, what do you do next? And they go, square root. And I go, you're going in circles, dude, because if you square root, then you're right back where you started. Then you're going to square it, then you're going to square root, and then you're going to be on this forever, like infinity. So, no, we don't square root both sides. Sorry. So, what do I do next? think you need a drink of water. So what do you think I do? Y- yes. Sorry, I had that drink of water. Um, you want to do this instead because you created yourself a problem. Um, tougher to factor. This is easier. Oh, did you hear what I just said too? There we go. I had something to lodge in my throat. Okay, so yeah, if you subtract that x squared, you wouldn't really be able to factor as easy. So what is the factorization of x squared minus 7x minus 8? It's a simple MA. So what does that become? So it multiplies the negative 8 and adds the negative 7. Good. What does that mean x equals? Okay, now I kind of skipped over this. Notice this word that we have up here. Identify an extraneous solution as well. So we're going to solve, but do we have extraneous solutions? Here's what an extraneous solution is. You did valid math, but a solution may not work. And there's many reasons why this could happen depending on the question that we're dealing with. Solution may not work. So sometimes you do invalid math, and of course that's why it doesn't work. But in this case, we did valid work, and I bet you one of these answers don't actually work for the original question. And here's why, and I'll cover this. Let me get someone just to get someone else woken up here. Number 12, good. That's Ryan. Ryan, when I take this 8, and I'm going to get rid of these squareds for a second here because that's the original up here. When I plug in 8, what's 7 times 8? Plus 8. Do you think this works? Yes or no? Is that true? That's an absolute truth. 64 and the square root of it is 8, so this is a good solution. Now, we're going to have a problem right off the bat. X equals negative 1. Negative 1 equals. You should see that there's an issue right away. Anyway, what's 7 times negative 1? Plus 8? Is the square root of 1 negative 1? Yes or no? No way. So, and that's the problem. This is not a solution. You know what these both solve? They both solve this after I squared both sides. Because Ryan, what's negative 1 squared? What? No. What's negative 1 squared? What's just negative 1 times negative 1? Is that a dog back there? I hear something shaking. Gotcha. All right, so that's what's going on, and you don't really need to know that. What you need to know is when you solve these questions, especially when there's a variable on the other side, like Genevieve said, I noticed the difference here. You may very well end up with extraneous solutions that work here but do not work in the original. All right. And that's the problem. We're solving the original. So that did not work for the original. So that's called an extraneous solution. All right. So bottom line is you have to check your answers. Probably should check them. Yes. Yeah. No, it's possible. It's possible. Then if both didn't work, what would you say for the situation? No. Anyone? No solution. You got it. Good question. Okay, Hannah, you're up. Huh? What? Oh yeah, definitely. Yeah, definitely a possibility. Okay. All right. So we do have. All right, Hannah, you ready? You look so excited. Okay. So what do we do to both sides? Oh, square. Now on the left side, how do I square the left side? Hey, by the way, good factors are good. Oh, so you foil? Yeah, you're right. I tricked you into saying what you need to do because you don't just square x and square 2. So on the right side, it's just freedom. The square root of uh, the square root of squared, those cancel. But on the left side, you have to FOIL. So go ahead and FOIL and tell me what you get there. Good. You know what last hour told me twice? They said 2x on the first term. I wanted to jump out the window. Anyway, so x squared, what? Y- Plus 4x. There you go. You scared me. I thought you were going to say plus 2x, which is plus 4x, and then plus 4. Okay, then, okay, what do you have to do in order to solve for this? What do you think you have to do next? Look at the previous question. You got to get this equal to 0. Here we go with the factoring again, right? We definitely want to pull the stuff on the right to the left side. So what do you end up with when you subtract? Uh-huh. And then here you go yet again. You get a simple MA. And then what does that mean? X equals. Let's wake up somebody. Not that you were sleeping. I just like pulling this around because I think some people, oh, I'm not up. I'm just going to sit here and do nothing. 22. Ethan. Hopefully we can get that back on real quick. Rudman. Nice. -2. What's -2 plus 2? -2 plus 2 is 0. Is the square root of 0 equal to 0? True or false? True. And then -1 plus 2. Isn't that 1? Does that equal -1 plus 2, the square root of 1? True or false? Ethan, I'm sorry, Ryan, there you go. There's 2 answers that work. All right. Those were some of the questions that you asked. Sometimes none of them will work. Then you feel betrayed. Why did I even do this question? But anyway, sometimes that does happen. You have to check. Oh, now this is looking quite involved. Let's get somebody else here. Nice. 15 is new, I believe. Sebastian. Okay, Sebastian, hold off for a second. I want to climb into everybody's head here for a minute. Oh, man. So blah raised to the 5 halves. Sebastian and everyone else, you should know that this is all of this raised to the 5th power. That's what that means. And the square root of that. So I often show my students this when we get into this kind of section, because then I want to think about undo operations. So Sebastian, just tell me real quick, how do you undo square root? What do you do to both sides? So I'm going to put that right here. I'd have to square both sides. Okay. So I would have to square this side. But then how do I get rid of this 5th power? What would I have to do to both sides? Not square root. There you go. You'd say 5th root both sides. All right. And then I'm going to color that in green and put that 5 as an index right here. All right. So I'd have to 5th root this as well. There's a faster way of doing this, Sebastian. It actually is just take this blah raised to the 5 halves and raise it to the 2/5, the reciprocal power. Therefore, I squared both sides and I also 5th rooted both sides, but I did it in one shot as opposed to confusingly writing it like I did up here. But I did want to cover it like that so that you understand we're still doing undo operations by doing this. All right. So, Sebastian, whatever you do to one side, say it. So, what did I do to the left side? I raised it. Yeah. Go ahead. Okay. And then what this accomplishes, or another way of looking at it, what do you do with these exponents, Sebastian? What's the rule of a power raised to a power? You multiply them. And oh, it makes me so sad how many students don't understand that 5 halves times 2 fifths is 1. And I don't know why I'm changing colors. And I don't know why my pen just stopped working. Okay. This is all raised to the first, which I would not have to write that. Hey, and then what's 1 to the 2 fifths, Sebastian? It is 1. 1 to any power is 1. The fifth root of 1 is 1. 1 squared is 1. So it's still just 1 here. Then what are you going to have to do to solve for this? Okay, I like all your answers, so I'm going to move on. Here we go again with the simple factoring. Boom, boom. 23. Mary, go ahead and factor that. So what's the factorization of x squared plus 5x plus 4? Mary? Oh, there you are. So what multiplies to 4 and adds to 5 because this is 1x squared? So what does that mean for these parentheses? Hopefully it's plus 4 plus 1, right? What does that mean x equals? Okay, and then we have to check these answers. Boo. All right, so we're getting to the realm where we got to check the answers because, okay, that one I don't have. All right, good. 13, lucky number. Lauren, nice. So when I plug in -4, yikes. Okay, let's plug in -4. -4 squared is 16. All right. Lauren, are you there? And then -4 times 5 is -20. What's 16 plus -20? 16 plus -20. Plus 5. Good. Is 1 to the 5 halves equal to 1? True or false? Oh, the 1 to the 5th power is what? And then what's the square root of 1? So is 1 to the 5 halves equal to 1? Yes or no? So -4 works. Circle it up. And then -1 squared is 1. -5, we get in the middle term. What's 1 plus -5, Lauren? Plus 5. So we get that again. True or false? True. So we got to check these by plugging them in to make sure that they actually work. Okay. And in this case, we did get 2 that worked. So we're good to go. Okay, good. Nice. Hopefully everyone feels alive when they get picked. Like number 17, John Mildice, the Jack attack. Okay, here we go. Oh, Jack, you got a tough one here. You ready? What do you think you're going to do to both sides when you see this question? Ooh. Okay, so that would take care of this, but then cube rooting it, you still have a 2 down there. I think there's something better you can do that ultimately takes care of both sides. So maybe look at the left side and do what we did on the last question. 2/3. So basically what you should tell me is mathematically raise the left side to the 2/3 power. That's what you want to tell me. That's how you want to word it. Whatever you do to one side, say it. Okay, and the reason that took care of this is what's 2/3 times 3? What happens with that? And what do you end up getting? It is 2. Again, we're changing colors randomly. I don't know why. This is to the first power. Oh no, this is to the second power. Well, that's not a big deal. We had a question like this earlier. What do you got to do with the right side? Oh no, you don't want to be square rooting, and actually, it wouldn't have been cube rooting anyway. We got rid of like all of our exponents, and if you said square root both both sides, then this would have a square root on it, and it's not solvable. You'd have a variable stuck in a radical again, and you're kind of going in circles. No, I want you to do something with this. Hey, good factors are good whats. Hmm. Okay, so x plus 18 equals what do what do we get when we FOIL that out? Nice. Oh, what's negative 2 times negative 2? Okay, and then okay, so let's all look at this again. This is why I raised to the 2/3 power. It actually got me a workable situation where I can definitely solve, which is going to be by factoring again. So what are we going to do next, John? And then I'll have someone else go. Yep. And you get x squared. Okay, you're done unless you get picked again. This is so much fun. 7. That's a repeat. Genevieve, your lucky day. What is this factored? Okay, I didn't like what you said there. You said x minus negative 7. Is that what you meant? There you go. All right, so x squared, 2x, and negative 7x is negative 5x. Negative 7 times 2 is negative 14. What does that mean? X equals? Okay, so we're getting this factoring coming back big time. Oh, no. Now I got to check these answers. Okay, so Genevieve, what's 7 plus 18? Okay, so let's hold off on 25 to the 3 halves. Does that equal what's 7 minus 2? Is this true or false, do you think? When I plugged in 7, this is what I ended up getting. True or false? Oh, what's this 2 on the bottom mean? What does that mean I'm doing to 25? And not the cube root, the square root. What's the square root of 25? And then this, I don't know why I just changed colors again. Hopefully that's not confusing people. Is this true now? So we have to be able to plug these in order to verify, is this good or not? And then, so I circle this up. I don't know why I'm changing colors again. Stop changing colors, Mr. S. And then negative 2 plus 18. What's negative 2 plus 18? 16 to the 3 halves. And then what? Oh no, what's negative 2 minus 2? Could this possibly be true? Oh no. What's the square root of 16? What's the square root of 16? So is 4 cubed, change of colors again, equal to negative 4 cubed? True or false? False. This is an extraneous solution. Okay. Cross with, hey, red and green, just in time for Christmas. Okay. Yeah, so you got to check those answers. We ended up with a false, false, false. Oh, last but not least, this is a disaster. And I'm probably only going to have time for one, because that's what happened last hour. Oy. So hopefully everything's good so far. Hopefully everything, Alessandra, he got picked there. Hopefully everything's fine right now. The idea of opposite, you know powers here, raising to the reciprocal power, not a big deal. We kind of had a big deal with these where we had X on the left side. We had to square both sides and then do some factoring and check our answers. Because now we got a real tough one. Check for extraneous solutions, it says. Oh no, Alessandra, what is completely and totally different with this one compared to everything we've dealt with up to this point? Absolutely. I'm just going to get to it what you need to do. If you squared both sides right now, you would have a nightmare foil right there. You just have to imagine. I'd take root x plus 4 times a root x plus 4. That'd be great. But then the middle term, you'd have it would be a mess. So you don't want to do that yet. What you want to do is try to separate these radicals into two separate sides. So add root 3x. Still going to be a bit of a mess, but we are going to go ahead and square both sides now. What's the left side become when we square both sides? Alessandra? That's a good thing. The right side, not a so good. We got a foil. Oh, no. So this squared means this times itself, and you might want to do that. What are you getting first? What does that become? But let's just go ahead and simplify it. Yeah. And then what does that become? And then that become? Too much. No, you can't take the 2's and multiply them on the inside. So it's just negative 2 root 3x and another negative 2 root 3x, which is negative 4 root 3x. These cannot be multiplied. One's inside the radical, one's outside. Okay? And then what's negative 2 times negative 2? Now, we still have a radical, don't we? So what do you think you're going to do next? No, because you have a square root already. Yeah, but we don't want to do it yet until we get this 4 and the 3x taken care of. What do you think you want to do with those before you want to square again? Because you're right, we do want to square again. So we want to move them over. How do I move this plus 4? What operation? Then look at what happens nicely. Ooh, that's nice. And then subtract this 3x. We end up with, I don't know why I put 32 there. That was a brain mishap. So I just get negative 2x equals negative 4 times the square root of 3x. So here's what's nasty about this. We have to square both sides one time, and then we're going to have to do it again. So we're going to have to square both sides one more time. Do you want to divide by that negative 4, Alessandra? What do you think? Do you think that might be a good idea? Yeah, let's go ahead and do that. We did it last hour. So I don't want to square yet until I get it completely isolated. Unfortunately, we get a fraction. Oh well. Now we're going to square both sides again. So we have to square both sides twice in order to get rid of a couple sets of radicals here. Big pain. Hey, what's 1/2 squared, Alessandra? See if you know your fractions. Oh no. What's 2 times 2? There you go. It's 4. 1/4, I mean. And then equals a free 3x. I think you've done enough. Let's get this last person of the day. Oh, come on. I hit that. 19, right after 18, which is Emily Ann. Hey, what are you going to do next in order to solve for this? What do you think, Emily Ann? No, you know what happens on that? You lose an answer. You lose an answer when you do that. So you cannot divide both sides by x. Go ahead and say what you were going to do. That would be helpful. I guess that would be helpful. Multiply both sides by 4 and you get x squared equals 12x, right? Right? Okay, but then what? People often forget about this. Why would I still subtract 12x from both sides? And what would be the factorization of this? Like what kind of factoring would this be? People often forget it, this factoring. It's the very first thing of factoring you should look for always. Absolutely. What is the GCF? And then what does that means left over? And then what does that mean x equals? You would have lost that 0 if you divided both sides by x. Do you understand what I'm saying? Yes? Okay. So you don't want to divide both sides by x ever when you're solving. Now, the reason I'm moving these up here is we won't be able to do the other one because of time, but we also have to check our answer. Okay. Hey, one more time. This is great. Hmm? Going through the hey, all right, Alessandra. Hey, when I plug in 0, what's 0 plus 4? And then minus, what's 3 times 0? Is this true? The square root of 4 minus 0 equals -2? True or false? That is a false. That is an extraneous solution. All right, now let's plug in 12. What's 12 plus 4? And then, holy cow, what's 3 times 12? True or false? Square root of 16 minus the square root of 36 equals -2. True or false? Square root of 16 is 4. Square root of 36 is 6. What's 4 minus 6? It's true. So non-extraneous solution, x equals 12 there. Okay, so worst case scenario, we had to square both sides, clean it up, and then square both sides again. And then we ended up with a GCF factoring. Going backwards, when we have these powers that are fractional exponents, you can raise by the reciprocal power and then do your algebra after that. Same thing with this one. Be wary when you have these questions. You do have to square both sides and then end up factoring. And then we ended up with those real easy questions to start off. When you only got simple, um, things like this, it works out real nice. Go ahead, Ethan. You can go ahead and ask. Absolutely. Yeah, I just wanted to kind of recap. It's not showing up very well here. There we go. Okay, there's the last one. All of it in its glory. Yep. No, it is not. The square root of 4, the square root of 4 is 2. The negative square root of 4 is -2, and they are separate. You're not solving an equation, you're plugging in and evaluating. So the square root of 4 is +2. The only way that you get -2 out of that is if it was the negative square root of 4. So this is only 2. Right? So that would definitely not be the case what you said there. Okay? Got to make sure there's a difference between what's the square root of 4 and solving x squared equals 4. These are two different scenarios. This gets me a plus minus. This does not. Okay? There are two separate um, radicals going on there. Positive square root of 4 is 2, negative square root of 4 is -2. All right? Not plus minus. Oops, sorry. Snuck up on me that cough there. Okay, so yeah, tough stuff. So as a recap, remember, especially those that aren't doing, I'm going to put together a playlist right away, right when I leave you guys right now. 4 questions maximum from each section, the ones that I kind of like from each one. Do remember about the graphing part because that's the 4-3 section that we did first. And then our bell work was real nice. Those kind of questions are going to come up there. So, all right, we'll see you. If there's any other questions, you can stay on. Absolutely. Mhm. You got it.